In this program, we're going to look at how to compare strings. We'll start by checking to see if they are equivalent. So I'll call this project String Comparisons and make a class and call it String Comparisons and take a free public static void main string args. Some documentation at the top. And you see we're going to learn how to use, for one thing, a dot equals method and not use double equal signs. Double equal signs are good for primitive data. Objects, such as strings, we should use a dot equals method. So we're going to come up with a couple names, name 1 and name 2. You can call them whatever you want. I'll make the first name, name 1, Snoopy, and name 2, Clifford. You can tell just by looking that these two strings are not equivalent. We'll now learn how to use the dot equals method to compare two string objects. Dot equals, as I'm writing here, will do a character by character comparison. So if name 1 dot equals, and then inside parentheses, we'll put name 2. So we're going to check for the equivalency of name 1 against name 2. If it turns out they are equivalent, we'll print and display this statement that name 1 is equivalent to name 2. Otherwise, we'll display a statement that explains that the two variables are not equivalent. I'll just copy and paste this and put the word not inside. Also a little documentation to end this if block. Eventually I'll get it typed correctly. Once again, we're learning how to use dot equals. And Snoopy is not equivalent to Clifford. If I change name 2 to have the exact same characters as Snoopy in the same order, now Snoopy is equivalent to Snoopy. Java is case sensitive, so when I start Snoopy with a lowercase s, the two are not equivalent. Again, in a character by character comparison, they are not the same. So if I capitalize some different words in the lowercase Snoopy at the start, they are not equivalent. They are not exactly the same. Again, Java is case sensitive, but if you want to ignore the case, we also can use dot equals ignore case to compare the two string objects. And then it doesn't matter which characters are uppercase or lowercase. In the interest of time, I'm going to copy the code I had earlier and change where we have dot equals to dot equals ignore case. And change a little bit of our display to reflect what's going on, letting users know that they are equivalent if we ignore case, that they are the same. And then we'll be able to test this out. And now, if you ignore case, Snoopy with the capital S is the same as Snoopy with the capital OPY at the end. If I change name 2 to Clifford, Snoopy and Clifford are not equivalent even if you ignore case. I'll make some upper and some lower again, and as you see, it's not equivalent, but if you ignore case, those two are equivalent. We can use dot compareTo to compare two strings, especially when we're trying to find which one comes first in lexicographical order. Dot compareTo returns an integer. So name 1 dot compareTo name 2 will return an integer of some type. And the key is it positive, negative, or 0? So we'll check to see if it's greater than 0. If it is, then that means name1 comes after name2 in lexicographical order, which for the most part is alphabetical order. Capital letters precede lowercase letters, and all characters are considered, including symbols, space, numbers. If .compareTo returns a negative number, which means the result is less than 0, then name1 comes before name2. Let's check this out so far. I forgot to put a space before the letter C. All right. Snoopy comes after SNO with the capital O in lexicographical order. Not a surprise, I told you that the capital letters precede lowercase letters. Snoopy comes after Clifford in lexicographical order. If I reverse name1 and name2 and put Clifford in the name1 spot and Snoopy in the name2 spot, now we'll get Clifford comes before Snoopy in lexicographical order. Here's Clifford starting with an uppercase C compared to Clifford with a lowercase c, and the uppercase C will come before the lowercase c in lexicographical order. Another possibility for .compareTo is it returns the value 0. That means they are in the same spot, they're the same thing. So one doesn't come before the other in lexicographical order because they're the same. So I go up here and make them exactly the same string. They're both Clifford, all lowercase. They are the same in lexicographical order. One does not come before the other. But I'll turn name1 Clifford with a capital IFF. That's going to come before a lowercase IFF. I'll document the end of this so I know what this purpose of this block was. It was to teach us how to use .compareTo. But maybe you want to ignore case when you're comparing these strings. Well, we have compareToIgnoreCase. We still have the same integer result getting returned. It could be positive or negative or 0. I'll edit the code so this says .compareToIgnoreCase, and then capital and lowercase characters won't make a difference. So now I have Clifford and Clifford's. The first one has some capital letters, the second one doesn't. But with .compareToIgnoreCase, they look the same in lexicographical order. All right, a very important point. Strings are objects, and when we compare objects to see if they are equivalent, we should use .equals. A double equal sign checks to see if they are referring to the same object in memory in the same location. That is not the same thing. I'll try to give you an example here to show what's going on. And in this time, we're going to use the word new. So string cookie flavor equals new string chocolate. I'll make another string and call it ice cream flavor. Set it equal as a new string, also with chocolate. In Java, strings are very special objects that don't require the use of the word new. We're going to use them here to drive home a point. So if we check to see if cookie flavor double equals ice cream flavor, well, if that's true, we'll say that cookie flavor and ice cream flavor are referring to the same object in memory. If it isn't true, then they're not referring to the same object in memory. And our result is that they do not refer to the same object in memory. Every time we use new, a different location in memory holds a different object. So cookie flavor refers to chocolate over here in red. Ice cream flavor is that it refers to chocolate in a different memory location. They are two different, separate string objects that just happen to both have the word chocolate in it. And that's the job of a double equal sign. It tells us, when used in comparing objects, if they are referring to the same object in memory. I'll make another string, call it brownie flavor, and set it equal to cookie flavor. When that happens, brownie flavor is referring to the same object as cookie flavor. So, next I'm going to compare brownie flavor to ice cream flavor with a double equal sign. The result is they do not refer to the same object in memory. And a quick look at our picture, they don't. Brownie flavor is referring to this object over here on the left, and ice cream flavor is referring to the one over on the right. Two different memory locations, two different objects. If I use a double equal sign to compare brownie flavor to cookie flavor, which, as you recall, I set brownie flavor equal to cookie flavor, using double equals, these do refer to the same object in memory. They are referring to the same object in the same place in the memory. That's what double equal signs do when you use them to compare objects. Now, I will admit, with strings, sometimes double equal signs will serve the same function as dot equals. Because I specifically used the word new this time, I made sure that that wouldn't happen. But sometimes on the whim of the Java virtual machine, you will get away with it. However, you need to get in the practice of, when you want to compare objects to see if they are equivalent, use dot equals. Only use double equal signs if you're trying to see if they refer to the same place in memory. Double equal signs are great for primitive data, such as Boolean, int, and double, but for objects, we need to use dot equals. And strings are objects.